Welcome to this explainer. If you're gearing up for your Texas Science 904 exam, today's topic is absolutely crucial. We're unpacking Competency005F, which gets right to the heart of science education, the fine art of strategic questioning. Our main mission today, moving your future students from basic, concrete observations all the way up to high-level, abstract scientific thought. You see, it's not just about getting the right answer out of them, it's about completely transforming the way they think. Okay, let's dive into this. Here is our roadmap, which is honestly the perfect blueprint for your exam prep. We've got the power of the question, climbing the abstraction ladder, the question funnel in action, tools for effective discourse, fueling scientific practices, and finally, exactly how to ace this on the 904 exam. Section 1, the power of the question. Because we need to completely shatter the illusion that teachers are just walking answer keys. The real power in a classroom actually lies in the questions you ask, and there are three core purposes here. First, moving beyond recall. We're talking about pushing up Bloom's taxonomy, getting students to actually analyze and create. Second, and this is massive, honestly, making thinking audible. It lets us peek inside a student's brain, right? By forcing them to articulate their internal logic, you expose hidden misconceptions that a standard multiple choice test might completely miss. And third, driving inquiry. A good question shifts the entire vibe of the room, from you just delivering facts to them actively discovering evidence. Section 2, climbing the abstraction ladder. Let's move to and see how this builds into a framework you can actually use. You can't just throw a highly abstract question at a student who's staring at a brand new phenomenon and expect them to magically get it. You've got to guide them upward, step by step. It's literally a ladder. Step 1 is the concrete phase, focusing strictly on direct sensory data and observation. Then, step 2 is the bridging phase, where you prompt them to connect those raw observations to underlying scientific principles. And finally, step 3 is the abstract phase. This is where you ask students to apply that newly formed knowledge to completely unseen systems. Section 3, the question funnel in action. Let's actually simulate a real-time classroom scenario right now using a classic boiling water experiment. All right, imagine your students are huddled around a hot plate watching water boil. To walk them up the ladder, you start right at the bottom in the concrete phase. You ask, what do you see happening to the water as it boils? Notice how that's phrased? It only asks for direct sensory data. You want them telling you about the bubbles, the steam, the exact number on the thermometer. It's safe, it's accessible, and everyone gets engaged because anyone can report what's right in front of their eyes. Now, what's really interesting about this slide is the shift into the bridging phase. Once those initial observations are out there, you ask, why do you think the temperature stopped rising, even though we continued to add heat? The shift in cognitive demand here is wild. It's no longer just reading a thermometer. You're demanding a connection between what they saw, that plateau temperature, and the invisible principles of phase change and energy transfer. You're forcing analysis. Finally, we push to the very top, the abstract phase. You drop this on them. Based on our model of energy transfer, how would this system behave on a planet with a completely different atmosphere? Boom. You've taken the student completely out of your physical classroom. They have to rely entirely on their conceptual understanding of pressure and boiling points to predict an outcome in a totally unseen, hypothetical world. That right there is the perfect question funnel, moving them from concrete to abstract. Section 4. Tools for effective discourse. Because knowing the steps of the ladder is one thing, but actually facilitating this kind of conversation takes specific techniques. As future colleagues, let me tell you, keeping the momentum going when a student gives a half answer or just gets stuck is tough. The source material highlights two massive game changers: scaffolding questioning and open-ended prompts. Scaffolding means sequencing your questions so that the student's previous response becomes the exact blueprint for your next question. You're basically building the bridge right under their feet as they walk. And to do that, open-ended prompts are absolutely essential. Avoid yes or no questions like the plague because they kill the conversation. Instead, ask things like, what evidence supports your claim? Or how might we test that idea? Make the student do the heavy intellectual lifting. Wait time? Did that silence feel just a little bit uncomfortable? Good! That is exactly the point. Giving 3 to 5 seconds of pure silence after throwing out a high-level question is one of the most difficult but literally crucial skills you can master. When you pose an abstract question, students desperately need processing space to put together a complex evidence-based response. If you rush in to fill that silence, they're just going to default to simple, rushed answers. Seriously, Embrace the silence. Section 5, Fueling Scientific Practices. And this brilliantly illustrates how everything ties directly back to the 2024 text. Questioning isn't just a neat pedagogical trick. It is the absolute fuel for authentic scientific practice. Under the Scientific and Engineering Practices, or SEPs, questioning is how students engage with the natural world. For instance, when defining problems in engineering, your questions help students analyze a phenomenon and nail down the strict criteria needed for a solution. And for constructing explanations, questions are what guide them away from simple guesses and toward rigorous scientific arguments. Which brings us to the ultimate framework for all of this, CER, or Claim, Evidence, and Reasoning. As you push your students into abstract conceptualization, CER is what ensures they don't just float off into science fiction. Your questions constantly anchor them back to reality, demanding they justify their conclusions with hard, empirical data. It's like saying, okay, you made a claim about that new planet's atmosphere. Great. Now, what is the evidence, and what's the reasoning that ties it all together? Section 6, Acing the 904 exam. Let's get highly tactical so you are totally ready for Test A. So the crucial point is understanding exactly how Competency005F shows up on the exam. Look at the comparison we've got here. The test is going to give you a scenario where a student makes a completely correct observation. The trap? Choosing the option where the teacher just praises the student and moves on. Do not fall for that. The exam wants to see you pushing boundaries. The correct answer almost always involves the teacher initiating that bridging phase by asking a follow-up question, one that demands the student explain the why or the how. Which leaves us with this final thought to carry into the exam and eventually your own classroom. When a student speaks, are your questions ending the conversation with a simple, "good job," or are they just starting the inquiry? Mastering this question funnel and leading your students up the abstraction ladder is how incredible scientific thinking begins. Thank you so much for joining me in this explainer, and best of luck crushing that 904 exam.